We've been looking at how Microsoft Excel can help us improve the functionality of our hosted WordPress site. In the first videos, we looked at ways to produce almost limitless numbers of WordPress pages generated by Excel tables. In the last video, we set up a search function to scour those pages for matches for our search items, and decided that rather than search through each page, we'd use a keyword file which would greatly speed up our search. So how to create this file? Well, we could try by hand, but how about we use Excel to extract proper names from a page and make our keyword list with them. We're going to use a Visual Basic subroutine to extract keywords from our text. So we need to create an Excel workbook and insert a blank Visual Basic module. And as before, we'll keep the coding as simple as possible. Next, we'll insert into our workbook a worksheet and copy and paste our text to be analysed into cell D10. All the next paragraphs will be copied into the rows below D10. By the way, if you are copying from the web, it's a good idea to use PasteSpecial and a text option, otherwise you'll get the full page including images. In our Visual Basic module, we've set up a subroutine header which we've called proper name tagging. And like before, created some integer and string variables. N will be our loop counter again. We'll use pos to find out where our proper names are in a string. ASCII num we'll look at later. Row and col will represent row and column values as we run down our worksheet. Then we have strings for our lines of text and our output text. Lastly, we'll count how many words and keywords we find. So let's start. Select our worksheet, which we've called NNP, and select the top of our text, which we put into column D. For our example, we're using a 1500 word extract from a Wikipedia article on George Orwell's Animal Farm. As you can see, there's plenty of text to go through, and it should be a good test. Using the row and column property, we find the numerical values for the top cell of our text, which we'll use in our for next loop. But what about the bottom cell, which is likely to be different for each block of text we use? To find this, we'll start from the lowest cell in the column D, and using the end xlUp property, jump up to the bottom cell of our text. If we take the row property of this cell, we now have a top and a bottom. So now we can start to loop through our rows and put the contents of the first line into strLine. Well, now what? Well, it'd be great if programs could help us out with, I'm not sure that will work, or perhaps we should try something else, but they don't. They either crash or produce gibberish. So what can go wrong here? Well, how about finding our first line has nothing in it, which is what our first condition is checking. It says if our line is not empty, then carry on. The two opposite arrows mean is not equal. And the two lots of quotation mark represent empty. If our line is empty, however, we jump all the way down to the end of the conditional and on to pick up the next line. What we're trying to do in this subroutine is, by using the spaces between the words in our line as markers, chop our text up into individual words. We'll then examine each word to see if it starts with a capital letter, like most proper names do, and we'll collect these up in a file and ignore everything else. And for this we'll use another type of loop called the do-while loop, which, as the name suggests, loops around while a condition is being met and then ends when the condition fails. Which brings us to a second problem. What happens if there are no spaces in our line? For instance, if there is just one word or a number or a letter. The while loop conditional will test for this using the inString function. This will find the position of a word in a sentence or just a single character, and that character can even be a space. The function returns its place in the string counting from the left. So in the sentence, dogs like cats, the first space will be in position 5. Our routine will keep looping round, chopping words out of a line until there is only one word left, and the loop will end. So if our loop conditional in string returns 0, that's no spaces, then we might as well jump out of our loop and go and pick up the next line. Well, let's assume we finally get some words and spaces. We're going to use the inString function again to find the position of the first space and pass that figure to our variable pos. Now we need to find if the first letter is a capital letter, and to do this we'll use a combination of the ASCII and left functions. We use the left function to return a specified number of characters reading from the left of our line, and as we only need the first letter, here we specify just one. ASCII is a numerical code for each character on the keyboard. All uppercase letters occupy a range from 65 for capital A to 90 for capital Z. So if the ASCII code for the first letter of our word falls in this range, we'll assume it'll be a good candidate for a proper name. Our if condition is asking, is the ASCII value higher than 64 and less than 91? If it is, we can add the word to our outputText variable, plus a space to separate it from the next word. If not, we'll just ignore it. We've also got to protect the program from weird inputs. Because we don't know what our word is, it could be some sort of number rather than a string, for instance, we'll use the convertString function to make it acceptable, and increase our keyword count by 1. Now we must shorten the line to get to the next word. If the characters to the left of our variable pos made up our word, then everything to the right of pos must be the rest of our line. So we'll use the WriteString function to chop off our word and shorten our line of text. And we can increase our word count by 1. Now we'll keep going round the loop, chopping out words until our line has only one word left with no spaces, and the loop will end. When we've exhausted all our rows, the for next loop will end, and we can output our results to various cells. So now we can run our routine. We've added a button so you can see it work, and if all's well it should look like this. By the way, that was a real-time demonstration. It took less than 1/10 of a second, in which time we've cut over 70% of our text. Pretty good considering most Wikipedia articles are a tough test because they're so factually dense. But there's a lot of unnecessary text left. Obviously, in English, the first word of every sentence begins with a capital letter. We could easily add lines to cut those out, but we might also cut out keywords. We also have many repetitions of the same word, but names can combine in many ways, so getting rid of one keyword might ruin another combination. Basically, with such a simple mechanistic technique, we have to accept some errors and redundancy. Admittedly, Excel's 1/10 of a second does leave us some time to do the rest by hand, but before we give in, we'll see if we can use Excel to improve things further in the next video. In the meantime, thanks for watching.